Morning student. So in today's video we'll be continuing with the chapter Boolean algebra. So today we'll be discussing about Demorgan's law or Demorgan's theorem. So now Boolean algebra expressions, it can be solved using different methods. So we have seen two methods. There are more methods that we'll see later on. So in the previous video we saw that using the logical or and not operators, right? So or is denoted by the plus symbol, and is denoted by the dot symbol, not is denoted by the single quotation, that is the negation, or it is also inverted or inverse or complement. Okay, so it can be proven algebraically using different laws and theorems, and also through truth table. So we have seen that the laws and theorems were proven algebraically, okay, using the logical operators, and then using the variable and the logical operators, and then also through the truth table. So now De Morgan's theorem, it has two laws, so through which the logical operators and variables can be inverted from one form to another. That is, x will be converted to the x complement, or the negated version of x. Okay, so the inverted, or that is the plus symbol, it will become and. Okay, that is dot, and will become or, that is plus. So plus will become dot, dot will become plus. Okay, and x will become the x complement, or inverted complement. Okay, so here the first law states that when two elements are odd, complement or negated, then they're equal to the and of two individual negated elements. So here you can see that the two elements, that is x and y, when they are odd, that is plus, and complemented, okay, and complement, so within the bracket, that is x plus x or y, the whole complement equals to x complement and y complement. Okay, so here we have to prove that LHS equals to RHS, which can be proven algebraically and through the truth table. So today I'll be proving this through the truth table. Proving algebraically is already explained here in your textbook, so you can have a look at that, go through that one, memorize that. Okay, so you can prove it algebraically using the different laws. So De Morgan's laws or theorem is actually proven using the different laws that we have already seen in the previous videos, that is the inverse law, uh, idempotent law, okay, distributive law, like that. So second law is, the second law states that when two negated elements are AND together, then they are equal to the odd of two individual elements, that is x and y, the whole complement equals to x complement plus y complement. Okay, so these two laws, I'll show you how to prove it using the truth table. Okay, so here, so De Morgan's law proved using truth table. So the first law, we have to prove that LHS equals to RHS, that is this side equals to this side, right? So you will notice that in De Morgan's law, okay, the plus will be replaced by the and, that is dot, and the x will be replaced by the x complement. So here's a truth table, that is since we have two variables, so only two values will be entered, that is 0 or 1, true or false, right? So here x, y. So when we have two elements or two variables, so in the truth table, when we have since it is to be represented using rows and column format, so when we have two elements, the two elements, okay, when it is evaluated in the truth table, it can form four possible combinations of rows. So that is like 0 0 1 1, 0 1 0 1. So it will be like 0 0 0 1 1 0 or 1 1. So no more than this can be found, right? Because here you can see that 0, if when x is 0, y is also 0. When x is 0, y is 1, interchange. When x is 1, y is 0, and when x is 1, y is 1. So no more than these 4 rows can be formed between x and y. So when x and y, okay, so x inverse will be the inverse uh, of this, that is the inverted of this, that is 0 inverted is 1, 0 inverted is 1, 1 inverted is 0, and 1 inverted is 0. Okay, in here the y's complement is 0 is becomes 1, 1 becomes 0, 0 becomes 1, and 1's become 0. Yeah, so that is the complement, that is the inverted form. So here you will also observe that here, so now we have to prove the left hand side and the right hand side. So the left hand side here is x is 0 and y is 0. So so we have to negate the whole. So 0 plus 0 becomes 0. So the negation of 0 becomes 1, and then 0 plus 1, 0 plus 1 becomes 1, and the negation of 1 becomes 1's complement becomes 0. Then 1 plus 0, that is x plus y, right? X plus y, 1 plus 0 becomes 1. So the 1's complement is 0, and then 1 plus 1 is 1, and the negation of 1 is 0, right? So similarly here, so on the left hand side we get the value 1 0 0 0. So on the right hand side we have x complement y complement, that is 0 into 0. So that becomes 0 complement is 1 and 0 complement is 1, so we get the value 1. Similarly here we have 0 and 1, right? So when we find the complement of that, we get 1 and 0, so we get 0. Similarly here 1 0, so it becomes 0 1 and then 0, and then here 1 1, so the negation becomes 0 0, and then we get the value 0. So if you see these values that you get, it's same, LHS equals to RHS. So hence we prove the first law using the truth table, right? So using the logical operators and or not, we can by using the truth table we can prove the laws, all the laws similarly, right? So here you are learning about these expressions. Okay, later on you'll be learning about the logic gates. So how you'll be using the logical operators to form the gates, that means the circuits, for the digital circuits. Okay, and so this is how the data formation works in the digital circuits. So now in the second law we have x and y same, okay, and then x inverted, y inverted is also same. So now we just have to prove the LHS and RHS. So here, as you can see here, x into y, or x and y, so 0 and 0 becomes 0. So the negation of 0 is 1, and then 0 and 1, that is x into y, becomes 0, and 0's complement is 1. So we get 1 1 0 0. So similarly in this here also you can see that 0 plus 0, that is, first we evaluate this 0, that is the 0's complement plus 0's complement becomes 1 plus 1, so we get the value 1. So since you already know the truth table of the logical OR and logical AND, right? So we know that anything multiplied by 0 becomes 0, anything multiplied by 1, that is 1 into 1, becomes 1. Similarly here, that anything added with 1 becomes 1. So the last one is 0 plus 0, it becomes 0. So if we compare the left hand side and right hand side, both are true. So we prove the second law also. Okay, so similarly based on that, there are some algebraic expressions in the textbook also. Okay, so you can see step by step the different laws that are used, the different laws like inverse law, okay, So all those laws, just go through that, okay, try to memorize all those, okay, and try to yeah, work out on that. So let's prove some more examples using the truth table method. Okay, here we have x plus, and within the bracket, x into y equals to x. So we have to prove that left hand side equals to right hand side. So whatever we evaluate, it should be equal to x. So here we have four possible values. So x is 0 0 1 1. Okay, so first we multiply x into y, so that is x into y, 0 into 1. So here there is no negation. 0 into 0 0, 0 into 1 0, 1 into 0 0, and 1 into 1 1. Then finally we add the result with x. So here we get x is 0, right? X is 0, 0 plus the value we get here 0, which gives 0. Again 0 plus 0 we get 0, 1 plus 0 we get 1, and then 1 plus 1 we get 1. So if you compare the left hand side and right hand side, both are same, so hence we prove this. Next, again, x plus y equals to y plus x. So here also you can see that this is very simple table. Okay, you can see the outcome is like 0 1 1 1, again here 0 1 1 1, right? So no matter, that means the arrangement or the order of the operands does not matter in the logic circuits. Yeah, because the output will be same. Now here we have in this truth table that we have three elements, x, y, and z. So here you can see that when we have to evaluate this is in the format of 2 to the power 3, so which can form 8 possible combination of rows. So here we have formed 8 possible combination of rows. So the first order is, so like 0 0 0 0 0 1 0 1 0 0 1 1, like that. So we have first 4 rows of x is 0, next is 1, okay, similarly 0 0 1 1 0. So you can put this in random orders also, okay, but the outcome will be same only. So these are the only possible combinations that can be formed out of these three operands. Yeah, so first we evaluate this y plus z. So when we do that, y is 0 and z is 0, so we have 0 plus 0 0. Okay, so I'm sure that by now you figure out how this works, right? So here also, after that, we find out, we multiply the result of this with x, so we get these values. Then again, we, on the right hand side, we multiply x into y, so we get these values, and then x into z, we get these values, and finally we add the result of this with this, so we get this value. So if you see that, okay, the left hand side is 0 0 0 0 0 1 1 1, and on the right hand side, that is this one, we get the same values, that is 1 1 1 at the bottom, right? So LHS becomes RHS. LHS is equal to RHS, so hence we proved that. Okay, similarly there are more of these expressions that we have to solve algebraically or using truth table. Okay, go through all of those, solve it yourself, okay, and then yeah, as much as possible try to solve all the expressions that are there in the solve exercises also. Okay, so if you have any doubts on this, you can ask, right?